So we end up with this one right here. So we want to move this decimal over to behind the 3 right there. That's the first non-zero one. So 1, 2, 3, 4, 5, 6 places. So we end up with 3.24 times 10 to the, we had to move it over 1, 2, 3, 4, 5, 6 places. So it's a positive 6. And we're going to divide that by, and we had to move it behind the 1 there. So we have to move it over 1, 2, 3, 4 places. So that had to be 1.8 times 10 to the positive 4th. Okay, so here we're saying 3.24 times 10 to the 6th divided by 1.8 times 10 to the 4th. And now we have to use a calculator to figure out what that is. So we get 1.8 1.8. We have 10 to the 6th over 10 to the 4th. 6 minus 4 is 2. So 7.8 homework continued. The level of some blood components are usually expressed using scientific notation. For example, red blood cells are commonly expressed as 10 to the 12th power cells per liter, abbreviated as 10 to the 12th power per liter. And white blood cells are commonly expressed as 10 to the 9th cells per liter. Write the following amounts without using scientific notation. So the first one we have is 5.2 times 10 to the 12th. And since this is a positive exponent, we're going to have to move this decimal place over to the right. So we go to 5.2. We're going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places, which means we have to add in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So we end up with 5, 2, 0, 0, 0, 0, 0, 0, 0, 0. 0, 0, 0. 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So the first 3, we have a comma there, we have another comma there, and we have another comma there, and we have another comma there. So we end up with, these are 1/10 thousandths, so these are thousandths right here, these are millions, these are billions, this is trillions. So it's 5,500,000,000,000. Okay. So let's try the next one. And this is per liter, technically, so we should put this per liter. All right, so this red blood cells per liter. Next, we're moving on to white blood cells per liter. So we start with 9.5 times 10 to the 9th power. So we have 9.5. We move it over 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And we fill them in with zeros. So we put 1, 2, 3, 4, 5, 6, 7, 8 zeros there. And that gives me 9, 5, 1, 2, 3, 4, 5, 6, 7, 8. There we go. So thousands, millions, 9,500,000,000, or sorry, 9,500,000,000 per liter. Okay, now what about the next one? Write the following amounts using scientific notation. So let's say we have 3, 8, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 per liter. All right, so this decimal is going to have to end up behind this 3 right there. So we would have to move it over 3, 6, 9, 12 places. Okay, so 3.8 times 10 to the positive 12 per liter. Okay, now what about D? Well, that one has 6, 7, 0, 0, 0, 0, 0, 0, 0, 0. So we'd have to move that over 3, 6, 9 places from here. So it'd be 6.7 times 10. And since this number was larger than 1, it's going to be a positive 9. So a brick wall 13 meters by 24 meters is 0.48 meters thick. Under particular temperature conditions, the rate of heat flow through the wall in calories per second is given by the following expression. Calculate the value of this quantity. Okay. So we have a 1.5 times 10 to the negative 4th power. And I'm going to convert everything here to scientific notation. So this is going to be 1, 2 over there. So this turns into 1.3 times 10 to the 1, 2, 3 places. So a positive 3. exponent. Over here, we're going to move the decimal point over 1, 2, 3 places here as well, so that turns into times 2.4, that's a 4, times 10 to the third power. And on the bottom, we could even turn that, if we wanted to, 4.8 times 10 to the first power. All right. So we would end up multiplying this by 1.3 times 10 to the third power times 2.4 times 10 to the third power, and the whole thing would be divided by 4.8 times 10 to the first power. So we have to simplify all these. So I'm going to multiply 1.5 by 1.3 by 2.4, which gives me 4.68. Times 10 to the, and we have a negative 4 plus 3 plus 3. Right, so negative 4 plus 3 is negative 1. Negative 1 plus 3 is a 2. Let me put that over 4.8 times 10 to the first. Now we have to figure out what 4.68 divided by 4.8 is, which gives us 0.975 times 10 to the, and now we have 2 over 1, right? 10 to the second power over 10 to the first power. 2 minus 1 is 1. Now we're not done though, because we have to move this over one extra place, right? Otherwise that's not in scientific notation. Okay, or we can just say 0.975 times 10 is just 9.75. If you wrote it in scientific notation, it would just look silly, because it would be 10 to the 0th power, which just means this would all go to 1, and then it would just be irrelevant anyways. So either way, you're going to get 9.75. Let's try the next one. The capacitance of a certain capacitor in microfarads can be found using the following expression. Calculate this capacitance. All right, so we have 5.74 times 10 to the negative 8 power times 8.00 on top over 3.00 times 10 to the negative third power. All right, so I'm just going to rewrite this. So we have 5.74 times 10 to the negative 8 times 8 over 3 times 10 to the negative third. Okay, so I'm going to multiply the 5.74 by the 8, and we're going to see what that's equal to. And we get 45.92, so 45.92 times 10 to the negative 8 all over 3 times 10 to the negative third. So now we're going to divide 45.92 by 3. We have about 15.307. This is approximate. This is repeating. That'd actually be a 6, but anyways, the point being is that this is not exact. This is an approximation, and that we're going to end up with times 10 to the, we have a negative 8, and we're going to subtract the negative 3. So now we deal with that. So we end up with approximately 15.307 times 10 to the negative 8 minus negative 3 is the same as negative 8 plus 3, which would give me a negative 5. And that's a pretty close answer. This depends on where they want you to round it to, what this answer is going to be right here. So we'll see.